Tom here. I'm going to be making a small home climate monitoring system. It will include temperature, humidity, furnace and/or air conditioning. It uses this little ESP32 module and just a handful of other parts. Okay, here's all the parts we're going to need besides the case. This is our temperature relative humidity monitor chip, 3 opto-isolators, half a dozen resistors there, 3 capacitors, 3 diodes, the module, and a little circuit board. First thing we have to do is to prevent the circuit board from interfering with the Wi-Fi signal. So we're going to modify it slightly. We'll mount it in here. The first thing I'm going to do is drill out a lot of these holes. Our last pin is 3 from the end. So we'll start drilling away. We're removing the cores of those holes so we don't have any electrical interference. We have the played through holes drilled out. We're going to change bits in our Dremel tool and remove the end connector and any remaining amount of played through holes. And we'll also clean off the other side. Now help prevent any interference to our antenna. Just like that. Now we're going to need a slight pull-up resistor for each of the opto-isolators. I found that the inputs tend to float. This particular module has an RGB LED on this side and has one on this side. We're going to be using the pins that are connected to this RGB LED as our inputs. These are little 1/8 watt resistors. That's all we need. They're like 10K just to keep the inputs from floating. So these are going to be pulling the pins high. So there we go. We have the 3.3 volt and 3 pull-up resistors going to each of our input pins that we'll be using. These are open collector. The notch puts the output transistor on this side and the diode input on this side. We'll leave some room on this side for our input signals. I'm leaving my leads long on the back side for the moment. That way it simplifies connecting things up. The last pin, pin number 6, is not used. We're not going to be soldering that at all. So let's work on the input side. This is the circuit we're working with. Opto-isolators. So we need rectifier diode, capacitor, and a current limiting resistor. I chose a 2.7K 1 watt resistor. It's overkill, but at 2K and 20 milliamps you're looking at about half a watt or so. So making a 1 watt, making it a little larger, eliminates any problems with heat dissipation on a resistor. Because coming in from here on the cooling heat and auxiliary heat, that's going to be 24 volts AC, which is going to put about 33 volts at the top of that capacitor. So the first thing would be to put in these resistors. We're going to stand them on end. And we'll put them right next to the diode input. These particular resistors, the leads are fairly short. So to make them fit, I'm going to really bend that right around as tight as I can go. That gives me lead to go through the circuit board. And we'll solder those up. For the moment, I'm just going to tack them in over on this side. Sometimes you'll fill a hole next to it. Just clean out a little solder wick. Now our ground is going to be on this side on pin 4. Now these really nice small capacitors. The minus for the diode is going to be pin 2. So we'll place these capacitors with the minus towards pin 2. These are 50 volt, 22 microfarads. Again, we're just going to tack those in place for the moment, because we're going to use the component leads to make our interconnections. Next thing we need are the diodes. We're just going to mount those, but we have monitoring points then. This accomplishes two things doing it this way. The one thing is, if we want to, we can just hook our interconnect into here at the top of the diode, or we can just use that for a monitoring point. So we'll tack those in. Okay, so those are all tacked into place. We can flip the board over. And on this side, we can connect the diode to the resistor and to the capacitor all right along there. Doesn't matter which lead you use. Okay, so this wire here can be connected right to the IC. Okay, and the minus of the capacitor will go to pin number 2. Okay, I'm going to leave this length of wire on here, because that's going to be our common coming from our thermostat. So we're going to do the same for all these interconnects over here. Snip off some of the excess. Actually at pin 1. Bring our capacitor lead. Bring our capacitor lead over to pin 1. Should see my resistor lead to pin 1. So I'm bringing my resistor lead over to pin 1. The capacitor lead goes to pin 2, and again we're going to leave extra okay, and we'll do one more here. Again, we're going to take the capacitor lead, go around the lead of the resistor. Again, our resistor goes to pin 1. Resistor goes to pin 1. Anchor the resistor well. Solder to pin 1. Trim off the excess. Then the negative of our capacitor will go to pin 2. And again, we're going to leave this wire loose because that's going to be our common for our thermostat. So we could use a dab more solder. Going to make some short little jumpers here. And these are all come from the top. First jumper on. We'll tack that into place. We'll tack this end into place. Grab our next jumper. And we'll trim off any little excess pieces here. So this will be where we come in with our common down on this end here. So we have the inputs wired up. Sometimes what we can do is make a loop. This gives you a place sometimes to hook a wire into a circuit board. We'll just tack those into place so they don't go anywhere. Make sure we don't have any extra leads that might short out. So here we have our pull-up resistors. That's our 3.3 volts there. Pull-up resistors. And then from the pull-up resistors, we're going to need to get to the transistor part of the opto-isolators. So we'll just need a couple jumpers here to accomplish that. Then the other thing we're going to do is include a jumper from the emitters to ground. So let's do the collectors first. This first one is the easiest. We'll wrap it around the pin coming from the module. The emitter is pin 4. And we'll go to collector, which is pin 5. Okay, so we want to go to the collector from this pull up into pin 5. Pin 5 is the center pin. So we'll solder to the pin of the module. Also make sure the module is well attached. And to the collector. And that one is done. Now the others are going to be fairly easy as well, because if you looked on this side, the jumper's onto the respective opto isolator. Okay, so we have to figure going from here down to here, and then from there to there. And I think we'll color code them to go along with the LED colors. Green is the closest one, which is here. To come over to the collector. Okay, so we have the jumper for the green input. Now we'll make a jumper for the red input. This one's going to go from here over to there. That'll do. So flip it over. Okay, this end here goes to the collector. And we're going to take these two leads here and those little 1/8 watt resistors, if I can get a hold of them. Going to bring one around the chip lead, and it's going to stop right there because that's where our lead goes to the green input. I'm going to solder this fast here, clip off the excess. Similarly, we're going to take this little lead here, wind it around. Now this last lead here just has to be attached there because that's going to be our 3.3 supply. So it's not the prettiest thing in the world, but it looks like we're all connected. And we're already connected there. We don't need a jumper in there. So the final thing is we need to get a ground, and the ground comes from the nearest one is the second to last pin. So this pin here is a nice ground. So as not to confuse colors, because black was used for the common there, I'm going to use blue as my ground here. And we need a common going from the emitter, the emitter being on pin 4. So this is going to be the emitter, this is going to be the emitter, and this is going to be the emitter. To make things simple, so I need to run a jumper from here to here, and then from there to there to there. So to get the approximate length, I'm going to put that like that. Okay, so this would be my first jumper. Okay, we'll flip it over and solder it. Okay, so we got our first blue jumper in. Now we need to put the second blue jumper in. So the ground is this pin. And we'll probably just do that with a bare wire. We'll just leave a loop on that in case we want to check the ground from the top of the board. So that's most of the connections all done up. We're not using any of the inputs on this side. Just checking the work. Any things sticking up in the air that shouldn't be. Make sure that that's well connected there. Just put a little pressure, get that down in the solder there. That's much better. And again, get rid of anything that's sticking up that shouldn't be. We'll leave these here for now. The module is just tacked on in a few places. The next thing we need wires going to our sensor, our temperature humidity sensor. This has resistor and capacitor built into it, so you only need 3 leads. Otherwise, you have to supply a resistor and capacitor because there's 4 leads to the device. So let's make up our connections for that. So for this device here, I'm going to take this connector off. Okay, now I'm clean the rest of the solder off. Now you need a tool to clean out the holes. What I'm going to do is mount it this way in the box. Okay, so we've got the grounds hooked up, which is down here. Just have to hook up the thermostat leads, and we'll test those first. Okay, so I've got this 24-volt power supply, which I'm going to use as my test supply. Okay, so I got 24 volts there. Make sure we got 24 volts. Close enough. It's no load, so it'll be a little high. So now we'll do a smoke test. There's the common. That's the first input. We can check turn that around. ground. So we have 33 volts. Move to the next one. $33. And 33 volts. And flip it over. And .15 volts, so that's across the diode. .165 across the other LED on the opto isolator, and finally .164. So all the LEDs are being lit. Now we just have to test the board. Okay, to test our inputs, I'm going to power up the board with, first of all, nothing hooked up. Use the micro USB. The board should be booting up. Okay, that should flick on and off once a minute. So if I connect this up, that's the red LED. Green LED. And blue LED. So all my inputs are operating as I expect. Here's the blue, green, and red. So that's my three inputs. So I'll have to go get the computer and we'll watch the output, because this will send a serial signal out with the software that I put together, which it all through the Wi-Fi connects to my Wi-Fi and uploads it to my website. Once every minute, it'll get the status of heat, cool, or auxiliary heat, and it'll also give me the temperature and humidity with this device here. So we'll go take a look at that. So here's the circuit. Your three opto isolators, that's 4N25 or equivalent. We have our 24 volts AC coming in. Gets rectified to about 33 volts, give or take. Current limiting resistor, so we have less than 20 milliamps through the LED. A quick calculation, 20 milliamps drop through a resistor is going to be about a half a watt. I just doubled it up to a 1 watt. These 22 microfarad 50 volt caps, I happen to have some that are nice and small to fit on the board. So this is the common from the thermostat. I had to add these 10K, and the value is not critical, 10K resistors as pull-ups. The inputs wanted to float a little bit. You would think with the LED, which is over here, which has a pull-up resistor, would be enough to keep that floating high, but it doesn't. So these pull-up resistors just make sure that the inputs are high unless the circuit is energized. So we have pin IO16, which is over here, which is the red LED, 17, which is the green, and 18, which is the blue. Now, in the program, which I'm going to show you very shortly, the blue which is over on this side, is pin 16. And I set that as an output. So I can drive that low and turn that on whenever I want. The red and green are hooked up to other parts of the circuit which I don't want to mess with. The RX and TX data go through that. So when this thing sends anything out the serial here, the USB serial, you'll see that momentarily flash. Now the DHT22 modules, there's a DHT11 and a 22. The 22 is supposed to be more precise. The 11 is a lot cheaper. This one comes with a little circuit board attached that has a resistor and a capacitor on the back side, so you only have 3 wires to deal with. And these can go directly to ground, and we have a 3.3, and we have IO2, I think it is. I'm sorry, IO4. IO4, not IO2. This goes to IO4, and it uses that to communicate with the temperature and humidity module here. There's a whole bunch of other inputs available. There's analog, there's single wire communications, all kinds of features. This is a ESP32. The main setup is pretty much the same. Some only have 1 or 2 LEDs hooked up internally. They all work pretty much the same though otherwise. You'll find some that have fewer pins. My original prototype actually was using some of the pins over on this side as inputs, and then I was forcing this LED from whatever the condition was. But this is actually simpler because when one of these inputs is drawn low, the corresponding LED will turn on. So you get a good visual feedback of if your heat is on, if your AC is on, or if your auxiliary heat is on. And again, there's other pins available. It's just that these are hooked up to internal LEDs. And these are cheap. They're like, $10 or something like that. This, the temperature sensor, I think they're around $5. 4 N25s are dirt cheap. You can get a bazillion 1N4007s for almost nothing. Capacitors are cheap, resistors are cheap. So you can throw the whole thing together for, I don't know, less than 20 bucks. And then it's a matter of just finding a case. I found some on Amazon. Unfortunately, well, they came in a 5-pack, but unfortunately, they didn't come with any screws. And they use number 2 screws, which are really tiny. So one of these days I'll get over to the hardware store and actually buy some number 2 screws. So let's go see what this looks like in software. You can see that the heat is off, auxiliary heat is off, and cooling is off. I'm out in a fairly warm area right now. It's 83.12 degrees. Humidity is 64.5%. And it's uploaded the data to my host computer. A little bit about the code over here. Set up a couple constants. And then we have to include for the temperature humidity sensor. We're using Wi-Fi multi. What that allows you to do is specify multiple Wi-Fi networks so it can connect to any one of those. And of course, the HTTP client. So the start URL you would put in your website, and like update.php or whatever you're using. You put in your Wi-Fi SSID, the password, and for my situation I have a private key that I use. In the setup, we're going to be talking to the computer here over a serial link of 115K baud. Set up the Wi-Fi mode, add an access point that it wants to connect to. And then we're going to run through about 4 seconds, just make sure things settle. Then we're going to set our pins, our pin modes. The D2 blue pin is the illuminated blue pin that you see there. And that is ideally blue all the time. If there's a problem, it's going to flash either once or twice or 3 times depending what the problem is. I'm going to be getting location in case I get a 301 or 302 redirect. I'm not using the server header. These are headers that it's going to parse when I get a response from the server. And initially it's not redirecting. And it's going to start out using the start URL. So if URL is empty, then use the start URL. So in the loop here, we're going to get the heat value, whether it's a pin on or not, the auxiliary heat, and the cool. And these lines here, serial print line, is what's being displayed over the right hand column, right hand screen there. If the data is valid, or we're going to initially say the data is valid. So we're going to read the temperature, and we're going to read the humidity. True means we're going to do Fahrenheit. So if either of those turns back a bad value, then it's going to say fail to read from the sensor, and valid data equals 0. And then it's going to toggle the blue LED 3 times, 1 second between. So if it is valid data, then we're going to print out the temperature and the humidity over here on the right hand screen. Then we're going to check to see if the Wi-Fi is connected. If it is, we'll say so, and then we'll do our HTTP client. So we're going to build our request string using the URL, and we're going to pass in the values that we're looking at there. So we're going to begin with the request, and then we're going to also say collect these headers, and then we're going to do a get, an HTTP get. So if the code is 0, which means there's no error, then we'll look at the, if the HTTP code returned is greater than 0, then there's no error. If it's HTTP code OK, which is 200, then we'll look and see what we get in the return. And in this instance, we're getting the words connected and new record created. That's what's being returned by the web server. If it's a 302 or 301, it's going to say, oh, that must be elsewhere. So we're going to get the location, and that will be our new URL. And just for reference purposes, we'll say redirecting out to the serial monitor. If it's redirecting, we don't want to wait a whole minute, so later on we'll show what's happening there. If we get an error, then we're going to toggle the blue pin twice. Now you'll see a red flash every now and then. That's the serial data going out the serial port. Now if there is no Wi-Fi, then Wi-Fi connected equals 0, and we're going to toggle the blue button once. That should be an L in there. So if it's redirecting, redirecting equals 0, and if the Wi-Fi is connected, we're going to wait 1 minute. So we're sending data 1 minute intervals. If it's any other situation where the Wi-Fi is not connected or we are redirecting, we're all going to wait 1 second and then we'll go the loop again. It's not much code and it's very functional. So at the present state, the heating, the auxiliary heat, and the cooling are all off. The temperature out here is 81.86 degrees. Humidity is 71.90%. If I make the connection, 24 volts, our next reading will show that the auxiliary heat is on. The red indicator shows that the auxiliary heat is on, and on the screen the auxiliary heat is on. So we'll disconnect that. Hook it up to the heating terminal, the green indicating that the heat is on, and the heating is on, auxiliary heat is off, and cooling is off. We'll move the 24 volts over to cooling. Which is the blue. And the cooling is on, heating and auxiliary heat are off. We'll remove it completely. We just have our indicator that everything is running. And as you can see, all three are off: the heating, the auxiliary heat, and the cooling. Part 2, I'll be bringing you the web server side of this and how to chart the data. All this information will be on my Patreon account. Schematics, source code, so be sure to subscribe to my Patreon account. Thanks for watching, and I'll see you in the phase 2.